Hello, everyone. My name is Sergey, and I work as a software engineer in Fibery. In today's talk, I want to share some details of architecture behind our system. This talk doesn't require any knowledge about what Fibery system is. I will give you a brief explanation, and that will be enough. But before we start, I wanted to make some questionnaire. So, who actually have ever had anything about Fiverr, like since the logo, things like that? Okay, thank you. And who has ever touched the system? Who worked in the? So a few people as well. Okay. So Fibery is a work management system. What does it mean? So think tools like Jira or Airtable, Linear, ClickUp. I hope at least some names clicks with you, are familiar to you. So let's in my talk today, I have some notions to domain-driven design and domain models. I didn't know there will be an expert here. I haven't read Vlad's book, but yeah, at some time of my career, I was a big fan of this design approach and read a few books, unfortunately not Vlad ones. So let's review domain models of different tools that operate in this area, in particular project management area. So the first tool is target process. Why I've picked this one? So Fibery was born as a spin-off inside the target process company. And the initial Fibery team, me as well, we worked before in target process for quite a long time. In the target process, you can see there are a list of, it's a part of the domain. There is a list of entities and connections between them. So you have like tasks, bugs, user stories. They are somehow related. Or let's take another example. This is a Jira Service Desk. It's not important to read these titles. They just have projects, they have statuses, they have issues, and things like that. And at some point, working in target process, we started to get requests from our customers. They tell, okay, so your tool is good, but in our company, we don't use the term epic. We just use something else to name these things. We thought, okay, let's tackle with it. Let's introduce terminology. So basically, a user can come to the system and name this epic thing differently. But even after doing that, we still left with epics, left in API, for example, in integrations. So it was not a complete solution. And later, another company comes and they tell, okay, you have this nice hierarchy, but we are like thousands of people company. We have a lot of departments, a lot of levels, and we need more levels of hierarchy. And it was not clear how to map their unique process to our tool. So we have product specialists who specifically did that, but the mapping was never complete. And at that point, an idea arose in head of our CEO. So what if it was up to user to define the domain he operates in the system? And initially, when you start work with Fibery, we have this as our domain, so nothing. And then it's up to user to define which entities he operates, what are the relations between them, which fields those entities has. So okay, thinking in domain-driven design terms. So if we start to implement such application, what would be our application domain? And it appears it is actually quite simple. So you need just a few things. One of the things is database, and it's not related to relational databases. We decided to name a database in Fibery is a type of entity you operate. So, for example, user story or bug. And databases have fields, a list of fields. And also there are relations between databases, like user story can have a list of bugs, and bug will have user story field then. And this domain may seem very familiar to you. And indeed, if you think in relation databases terms, they have quite similar things. For databases, they have tables. For fields, they have counts, and for relations, they have actually relations. Those relations are a bit different in databases, relational databases. You just have, a foreign key column, that points to another table, and when you operate on domain entities level, relation has two ends. You have a link from user story to collection of its bugs, and from bug to user story as well. So in the beginning, we needed to make some design decisions, tech decisions, and one of the biggest things we needed to decide upon was storage. So where to store data of such application. We didn't have similar experience before, so we needed to come up, with set of requirements the storage needs to provide, and here is a list of them. But first, by the nature of our requirements, we wanted the storage to be able to dynamically modify the structure of its data. Second requirement, we wanted our storage to provide deep query possibilities. What does it mean? So in target process, we eventually implemented an API and a query language that allows you to query not only like a set of entities, but a deep hierarchy, like user story with a list of bugs and some particular fields of those bugs. And we discovered that such API simplifies things a lot on UI level and as well on backend level. And all complexity goes to the database level. So we wanted similar thing in Fibery. Third requirement, we liked open source more than vendor. It's clear. Fourth requirement is performance. Indeed, we needed to provide some performance tests to see how storage will perform on amount of data we planned to have. And the last one is data relations support. So it's basically we wanted those relations to become the core of the system. And as a user, you can navigate through relations like indefinitely through hierarchies. So we've reviewed various tools, storage types like document databases, graph databases. Also, we reviewed Datomic because Clojure was the language of our choice, and Datomic seemed like a natural fit there. But at that point, Datomic, it was, I don't know how it's now, at that point it was closed source. You should pay for it, and it was a rather noisy system. So we were afraid, how it would go. And of course, we tried relational databases here as well. So let's see how relational databases maps to those requirements. First, supports the dynamic modifying of structure of data. In relational databases in SQL language, you have so-called DDL, data definition language. So basically, you can call alter table statement or add column statement, and it just works. So you can modify data on fly, although it's not like a popular approach to do it dynamically. Second, provides deep query possibilities. So SQL is really rich language. Via joins, you can go as deep as you want. Open source. So indeed, there are plenty of solutions here. Closed source, open source. You can choose from them. Performance. In relational databases, performance is a well-known topic. So there are plenty of books written on it. You know how to think about performance. You know the complexity of various operations. Also, you have observability. Via query analyzers, you can see how your query is executed, and there are tools to optimize them, like different query hints inside various database providers, and also indexes. So it looked fine. And the data relations support, indeed, it's like relational databases. Even in its name, we have relation term, so it's built for that. So we decided it would be a nice try, and we decided to go with Postgres, like a default database for the web. And what I also wants to add. So Postgres basically it's designed for the following case. Its main case is like to have few databases, few tables in them, and a lots of data in those tables. In our case, we had the opposite situation. So user defines what entities he will have in Fibery, and by that we will generate Postgres tables for him. So indeed, those number of those tables can be infinite. Another thing is how to implement multi-tenancy. So usually you have a column for all your workspaces that users create, and you have the same table structure. And in that table, you have like workspace ID. And when you retrieve data, you just search for this specific workspace ID. In our case, it was not the case because the table structure is different for each workspace. And we needed some isolation. In the end, we went with Postgres schemas as an isolation level per each workspace. As I've told, Postgres is not designed for such case with many tables, many fields, and we met some problems on that way, which were really hard to think of before. Of course, we conducted some tests, but they were not enough. And but we were able to overcome those problems. I won't dig into a particular list, but yeah, it worked well, I would say. Another thing is programming language. So basically nowadays programming languages have converged. They steal ideas and syntax constructs one from another. And when you choose, you mostly choose on the platform. Most of us had .NET experience before with C# language. For Fibery, we decided to go with JVM, like the most mature and broad platform. And Clojure was the language of our choice. So why Clojure? It's a functional, immutable programming language. It's fun. It's maybe not so popular. There were some ideas that dynamic language can work better for such dynamic system as Fibery is. And also we explored ClojureScript on the front end, because those two have nice synergy when you use them together. First of all, of course, you can have shared libraries. And another thing that you can transfer code as data and thus allow some metaprogramming stuff. But after some tests, we decided that ClojureScript is not production ready. Development experience was poor. Wrappers around JS ecosystem were poor as well. So we went with just raw JavaScript. So you may wonder, how does code base of such system looks like? So in Fibery, schema is the core of the system. And by schema, I mean data representation of user domain. So basically, it's a list of databases user have and a list of fields and relations between them. One funny decision we've made in Fibery, we've made like schema and API for metadata and data the same. So for example, you have the same shape of API to retrieve the list of user stories, and also use the same API to retrieve the list of databases, or the list of fields those databases have. And it leads to some funny things. For example, in Fibery, you can build a board view where you have bugs as cards and user stories as columns. And similarly, you can build a board view where you have fields as cards and databases as columns. And it just goes for free. We don't have to change anything to support this case, although it's not very useful. Third property of schema is its dynamic nature. It can be changed at any time. And you have to adapt to think in the terms, because usually in applications, data structure is the thing you can rely upon. Here it's not. So you can make a query every time and it can fail because the field was deleted or because the database or relation was deleted. And you should get used to it. Another decision we made in the very beginning of designing our application is to make an event log from the day one. So what do I mean here? So in Fibery, API is an RPC call. Basically, there are just a few types of commands, like to create entity, to update entity, and to delete entity. Because of uniformness of schema and data, we use the same create for example, database or field as well, or relation, and to create the entity itself. So it's very, there are just 5 types of commands. And when any command is executed, we actually want to make actual change in Fibery database, but also we store correspondent event in the event log, and we want this to have transactional guarantees. To achieve this, we decided to store event log in the same Postgres schema, just in a table nearby, so we can do it in one transaction, and there will be never will be inconsistency there. Of course, later you can stream this event log to some system like Kafka or RabbitMQ. We use Rabbit, for example. Such approach of having event log from the very beginning to such types of system as Fibery is, it has some benefits. First, you can immediately start implementing additional functionality on top of event log. So, for example, you want to send a webhook to the third-party system, or you want to have notification system. You've immediately decoupled yourself. You shouldn't from now you shouldn't have to do it in Fibery core. You can write separate applications which sits on top of event log and do their business job. Another thing that you have history from day 0, although you don't show it to the customer. But eventually, when we implemented history in Fibery, because events were there, it's just customers got history from the day 1. Ideally, you want event log to be complete. And what I mean by completeness, at any point of time, you want to be able to write an application that takes an event log, replace events one by one, and eventually you'll get the same state as in your Fibery database. In practice, it's hard to achieve though, because you cannot predict anything, and bugs happens. But we aim for it. Okay, so till now I was talking mostly about backend parts. Now I want to switch to frontend. On frontend, React was a UI framework of our choice. And with the state management, we went with Redux. At that point of time, it was a popular library, and it has some benefits. First one is development experience is great. It has a great traceability. It's easy to see what happens in your store. It's easy because of immutable nature of Redux store. It's easy to reason about what happens there. As of now, I wouldn't recommend to go with Redux because of its performance problems. They can be hugely mitigated by using various caching selectors libraries, but this approach on a large scale appeared to be really subtle. So nowadays, I would just go with some mutable local storage system, and that's it. One thing that we decided to implement in Fibery to use is data normalization on the front end. So what does it mean? As I've told, Fibery API provides ability to query deep hierarchical structures. And imagine the response is returned, and it has, like in this case, it's a blog post with comments, author, and so on. And normalization is a process when you try basically to normalize it, to split those hierarchical response, to grab separate objects from it, and have relations by IDs there. So basically, to have the same thing as we do in relational databases. And there is an opposite operation, denormalization, where you can, from this normalized object, you can generate denormalized representation as well. To do normalization, you need to define a schema, and in our case, we already have it. It's Fibery schema. Such approach with storing normalized data locally has some benefits, and I will point them quite soon. Optimistic UI. So nowadays, UI's logic is shifted in many applications from backend to UI. Data is there, concurrency is there. Lots of things happens at once. You show the same data in many places on your interface, and you want them to be updated at the same time. And optimistic UI is like no doubt requirement for every application. And here I want to share how we did it in Fibery in a general way. So the author of UI component doesn't have to worry. Optimism is built in. So here is the structure. When user works on UI, let's say he changed some field in user story, for example, from 10 to 11. Two things happens at that time. First, we send an HTTP query to Fibery core, where we send a command to update actually data, and we generate some unique correlation ID identifier to this command. At the same time, we store an optimistic action in local store. So what does it mean to store optimistic action? We don't update local data in local store. 10 is still there. But we store an action, and basically it's a JSON where we tell, okay, for this user story, this field was updated from 10 to 11. And when the UI component selects data from the store, usually it's called selectors in most libraries, it doesn't select from the store itself, but rather it selects from optimistic store. And optimistic store is just a store with optimistic actions applied on top of it. So after user presses enter, he immediately sees 11 on his screen. At the same time, command goes to Fibery core, and then it's stored in event log. Then there is an event stream service, which responsibility is to handle a WebSocket connection with UI. And it just streams events, new events from event log to user interface. Eventually, event with the same correlation ID will be streamed to user interface. And in that event handle logic, we will do two things. We will actually update data in the store itself, and we will also dismiss optimistic action. So store will have the same data as on backend. Let's see. So what can go wrong here? So for example, update operation will fail. Well, it's quite simple. We then dismiss optimistic action from store. User will start see 10 again, and we will show some error to user, what has gone wrong. Another thing that can easily break is WebSocket connection between user interface and event stream service. Then actually user of a system, he will not notice like something went wrong. He will just continue to stack those optimistic actions inside his store, and those changes will actually be applied to database. Eventually, when connection will be restored, all events which happened in that time will be replayed, and optimistic actions will be dismissed from store, and your local store will get correspondent to actual database state. One thing that we didn't go with, and I regret it a bit, is like storing this local store in indexed database in browser, for example. And then with such approach, you can achieve like real caching. So imagine you've stored it in browser. When user reopens his tab like a day later, you can just populate the store from IndexedDB, replay all events that happened in that time, and user will just have all the data in local store. And when he navigates through the system, no request will happen. We will just use local data, which is updated by WebSocket connection. I would say, afraid to go with such approach, but another system, Linear, went with it, and they have nice presentation on YouTube, and they're known by their performance. So they made actually such approach the heart of the system. Yeah, and really recommend to watch the video. Okay. At that point of time, we've got okay, not so visible. We've got a system where you can define the structure of your data, you can change it, work with it actually, but it's not enough. And it was our initial release, but it's not enough for system to be usable. So user needs a lots of things on top of it. He needs like notifications, he needs history, search, formulas, he needs integrations, and many other things. So we went with like microservices approach to implement those additional functionalities, and we host everything in Kubernetes cluster. It was a cluster management solution of our choice. Funny thing about integrations is like usually when you want to integrate something in your system, you have defined like where to store it, integrated data. In Fibery, as we already have flexible domain, it was like a no-brainer. We like built an integration framework, and in some concrete integration adapter, let's say to ClickUp or to GitHub, you just define the mapping from ClickUp domain to Fibery domain. And you have to define, of course, code that retrieves data from external system. And then the engine itself, it does the mapping and generates needed Fibery entities, Fibery databases, fields, connections between them, and populates it with entities from external system. Okay, and the last slide for today is it's quite subjective. It's some reflections from my side. So I had an experience of working on the same domain in product companies for a long time, actually, around 10 years. So first it was target process, then it was some break, and then I worked in Fibery for maybe 3 or 4 years already. And when you work on the same product for one company, you have some advantage. You can see how decisions influenced later. What were consequences of different decisions? Because you can debate a lot when taking some decision, but will you actually stay in the company or see consequences of it? And I've seen some. And what advices I have? So first, it was a lot told about it a lot. I named it just rewrite. What do I mean here? So basically, you have a code base, and it somehow represents your system requirements in it. Eventually, it becomes stale. So eventually, it does not. There becomes in code base some code is left that is not like usable anymore. Terminology may change and things like that. And I was always a speed guy, so I always thought, okay, how can we mitigate it? Maybe if we have some subsystem and the requirements has changed, maybe we can build an adapter system on top of it that will implement needed changes, and at the same time we won't touch initial subsystem at all. And such approach has some advantages because you can do it faster. You don't do changes in initial subsystems, so you don't introduce regression bugs. Also, you save a lot of brain power because you work with subsystem like with a black box. But if you work in a product company which plans to stay for a while here, like 2 years, yeah, this approach, in my experience, just doesn't work because you increase complexity, and eventually it will and complexity doesn't grow linearly. The more such kind of decisions you make, the more complexity grows, and usually it's like some exponential graph. So after some time, I decided no more. So it's the best solution in such circumstances will be always to adjust code base and terminology, everything to the actual world where our system operates. Second point is about horizontal company structure. So our CEO is a big fan of horizontal company structures. Even in target process, we didn't have like managers. Same in Fibery. We don't have like CTOs, lead developers. Everyone is a developer. Yeah? And such structure, it leads to responsibility because your impact actually affects the system and you see it. And this leads that you start to care about what you are doing. Also, it introduced freedom and curiosity. So for a company of our size, in target right now we are 30 people. In target process, it was around 80. It worked like pretty well, I would say. The third point is also about responsibility. So on Fibery, if you build some feature, then it means you own it. No one tells you like fix a bug there. Yeah? It's up to you to track what's happening with it, what a user, what the user tell, yeah, what do they complain about. Basically, as for me, I populate my own backlog where I, prioritize those issues and fix them at some point in spare time or in the mornings, in such a way. Also, actually, to have this thing, you need to have three main things in your company. You need people to be responsible, and it naturally comes from horizontal company structure. Also, you need people to know actually what they're doing. But in case if they build it, they actually have the best knowledge in the system. And mandate, so they should have power, to decide, okay, that's time to rewrite this thing, that's time to fix this thing. And this also comes with horizontal company structure as well. Yeah. So that's basically it from me. Thank you very much for listening. For those of you, yeah. For those of you who haven't seen Fibery, I suggest to check application. Also, you may subscribe to our blog post. We don't write usual marketing bullshit, but we write about things inside company, various practices, how things goes on operational level, and things like that. Questions?